Part C. Fluid kinematics. Fluid mechanics is a science which studies fluid motion without reference to the forces causing motion or the forces resulting from the motion. The motion of fluids can be classified to various categories according to the principle of classification. With respect to time, the motion is classified to steady flow and unsteady flow. The steady flow is a flow which doesn't change with time, while unsteady flow is a flow where some or all of the flow parameters undergo a change with time. With respect to distance, the motion is classified to uniform flow and non-uniform. A uniform flow is a flow which doesn't change with distance, while non-uniform flow is a flow where some of all of parameters change with distance from one section to another. The motion of fluids can be classified according to energy losses, to ideal fluids where no energy losses occur, and to real fluids where energy losses take place. The motion of fluids can be classified also according to the mechanism of motion, to laminar flow and transitional flow and turbulent flow. In laminar flow, the flow particles move in laminar or layers, while in turbulent flow, the particles move at high velocity at a random motion in all directions. On the other hand, transitional states whose characteristics are average between those of laminar flow and turbulent flow. Velocity potential function. It is the science of kinematics. It is essential to define some definition concerning the different flow parameters as follows. Streamline. It is defined as a continuous line which, if drawn within the flow field, will give the direction of the velocity vector at all points on it, as shown in the enclosed figure. As the tangent to the streamline gives the direction of the velocity vector at any point, then the velocity component normal to the streamline is always zero. This means that there is no motion of fluid across the streamline will occur. Since the flow follows the boundary in contact with it in most cases, then the boundaries themselves can be considered as streamlines, as shown in the enclosed figure in front of you. If the boundaries change direction sharply or suddenly, the adjacent streamlines cannot follow this sharp curvature of the boundary, but will change their direction smoothly. Separation zones will be occur as this case. Hence, eddies will be formed, causing a continuous process of energy, as shown in the enclosed figure. Straight line is defined as the focus of a particle of the fluid in motion, while a stream filament or a stream tube is the path of a just streamline, as shown in front of you in the enclosed figure. Equipotential lines is the lines of constant or equal potential, and is sometimes known as normal or orthogonal lines. Anyway, these lines are normal to the streamlines as shown. Flow nets are drawn to indicate the flow patterns as cases of two-dimensional flow. The flow net consists of two groups of lines, streamlines and equipotential or normal lines, as shown in the enclosed figure, which show the flow nets for a few different cases. A flow net describes a picture of flow in a flow field as the direction of streamlines determines the direction of velocity at the various points. Follow by yourself, my dear. Flow nets can be drawn graphically or by using an electrical or magnetic analog. Moreover, two-dimensional flow is a flow where all particles are assumed to flow in parallel planes along identical paths in each of these planes. Hence, there are no changes in flow normal to this plane. On the other hand, three-dimensional flow is a flow where the flow pattern varies from section to section in the three directions, x, y, and z. Anyway, enclosed figure showing 2 and 3 dimensions flow. Principle of mass conservation, continuous equation. Follow by yourself. It is clear and so easy. Figure showing development equation of continuity for a string Q. Note that ρ1 v1 a1 equal √2 v2 a2 and so on, which means delta Q is constant. For incompressible fluid, density is constant and no fluid crosses the wall of a stream tube, and hence the rate of charge steady flow should be the same through all sections of an elementary stream tube, which is meaning Q equal V1 E1 equal V2 E2 equal V3 E3 and is constant, which is known as equation of continuity. To derive the continuity equation in three-dimensional form, take an element of flow in the form of parallelogram whose dimensions are delta x, delta y, and delta z respectively, and whose faces are parallel to the projected line. As clear in the enclosed figure, we show parallelogram element flow. My dear, follow the parallelogram and outflowing charge as shown in the enclosed equation described to you. My dear, look by yourself and continue that the continuous equation is formed and satisfied. Acceleration flow. If the flow is accelerated at some points at an acceleration, the acceleration can be resolved into two components, in the direction of streamline and in the direction normal to, as shown in the enclosed figure. Since the streamline gives the direction of velocity vector, then the velocity change delta v can be determined by drawing the velocity triangle with two sides parallel to v and v plus v, subtending the angle delta theta, as shown in the enclosed equation. The rest of previous equations follow it, my dear. Linear or horizontal uniform acceleration. Figure showing the horizontal acceleration on a liquid in an open container. Note that the resultant pressure force acting on the element in the direction of acceleration equals P1 minus P2 and also equal to mass multiplied by acceleration as shown. Follow the equation and it includes that the slope of liquid surface is constant for constant horizontal acceleration and the planes of constant pressure are parallel to the liquid free surface as shown. Vertical uniform acceleration. Figure showing vertical acceleration on a liquid in an open container. If the container with the liquid contained is accelerated in the upward vertical direction, the liquid free surface remains horizontal as is case, and the whole bulk moves as on solid. Vortex uniform acceleration. If a vessel or container containing a liquid is rotated about an axis, each particle of the liquid has the same angular velocity, and this type of rotation is known as forced cylindrical vortex. The liquid in the container moves as a whole as a solid, and no shear stress is exerted in the liquid, and the only acceleration is directed radially inward towards the axis of rotation. Figure showing the forced cylindrical vortex motion of fluid. Equation showing the corresponding pressure forces P1 and P2 acting on an element. Look and follow, my dear. Follow, my dear. Equation will evaluate the condition of integration and formula of revolution and its radius r. Figure showing parabola of revolution. Follow the equations, my dear, and look. Note that the fluid volume underneath the parabola of revolution is the original fluid volume. My dear, note that the original liquid circle divided the distance between vortex and top of parabola into two equal halves, as improved by the equation in front of you. Goodbye.